Hi there, welcome to Social Robotics Talk and another lecture on ROS2. In today's lecture, we are going to learn about parameters in ROS. Now, if you recall from our previous lectures, we learned about what node is in the context of ROS. Now, every node has certain settings associated with it. Those settings can be configured or changed during runtime or at startup without actually having to change the code of the node. So those settings are what we call parameters. So just to give you a simple example, in the previous lecture we had a package called TurtleSim, and when we ran a couple of the nodes in that package, we were able to see a simulation window, and we will see it again in this lecture shortly. But basically, when you open up that simulation window, it has a certain look. Now, if you want to change, let's say, the background of what that simulation window looks like, you have to change some value. So that value is what you can think of as certain parameters that is defined by a node that brings up that simulation. So simply put, parameters are the settings that are defined by the node, and each node defines and declares its own parameters, and the lifetime of basically a parameter is the same as the lifetime of a node. So now, to understand parameters, like what can we do with parameters, we will run through some examples. We will be using the same package called TurtleSim throughout our lecture. So if you haven't installed that package yet, first let's install that package. So the command basically is you have to say sudo apt install and then just install the package called ROS humble turtlesim. So I assume you have that installed. Now we are going to start up few nodes that are part of that package. As previously in our lectures we saw, in order to know what node to start, we need to know what it is, what executable it's part of. Executable is basically nothing but a piece of C++ or Python code that is part of a package. So I'm just going to again use the ROS2 package executables and name of the package. So I'm just running this command so that I can get a list of executables that are part of the package called TurtleSim. And the reason why I did that was because I wanted to basically start one of these executables. So from our previous lectures, you remember that these are the two executables that we ran, because one of these executables contains a node that starts the simulator. The second executable, which is the turtle.key, it contains a node that takes the input from the user through the keyboard. Okay, so I am going to start an executable called turtlesim node. So ROS2 run, and then name of the package TurtleSim, and I'm going to give the name of the node. This is the name of the executable. Okay, and then this is going to start a node that is inside the TurtleSim node executable, and then we are going to see a simulation window. I'm just going to put it like that. Now I'm going to start a second executable, which is this one. Run and paste. Alright, so these are the two executables that we have started. So if you want to get the name of the node, basically we can just use the command called ROS2 node list. This will give us a list of nodes that are actively running, and from our previous lecture. This is what we expected as well. So there are two nodes running. The name of the node is TurtleSim and Turtle Teleopturtle. So these are the two nodes running. Now, what can we do with the parameters? I would say the you don't have to memorize all of this. The best thing is we can just use the ROS2 help command, and basically we want to know what can I do with the parameters. So I'm just going to interrogate further. I'm going to say ROS2 param and help. Okay, so this tells me that these are all the things that I can do with the parameters that are defined by the node. So I can delete our parameters. I can use this command called describe if I want to get a descriptive information of a certain parameters, and rest of these. So maybe the basic one is the first one that we are going to use is we can get a list of all the parameters that are defined inside these two nodes that are running. So let's just create another terminal and make it small. So first thing is I'm going to get a list of all the parameters. So ROS2, similar to what I did, ROS2 node list. I'm just going to say the same thing, but I'm going to know what parameters are there that are actually defined by the nodes that are actively running, and it's going to give us a list of parameters. So as you can see, we have two nodes. The name of the node is Teleopturtle and TurtleSim. The parameters that are defined by the Teleopturtle node is all of these, and the parameters that are defined by the TurtleSim node are all of these. Okay, so that's one thing. So basically we have just used this command called list to get a list of all the parameters that are defined by the nodes that are actively running. Now the second thing, intuitively, what else can you do with the parameters? So remember, parameters are just the settings of the node. So what you can do is you can get a value of a certain parameters that is defined by the node by default, or you can change the value of that parameter by using this set command. So let's just use this get and set to see what is the value of the parameter called background B. So I'm going to say ROS2 and parameter get. By the way, if you don't know what is the syntax, you can simply go in here and we can say ROS2 param and then get and then h. It will tell you exact syntax that you should define. So here it says ROS2 param get, and then you need to give the name of the node and the parameter name. So in this case, name of the node is TurtleSim, and the parameter that we probably are interested in, let's just say background underscore B. Alright, so it just tells me the value of this parameter as defined by the node is integer, and its value is defined right now as 255. Now let's say you want to change this parameter. So let's say ROS2 param get, we want to change, so we'll say set and then TurtleSim background B. Now before you give a value, I think first important thing is, in this case we know it's an integer, so we can just give an integer value here. But if let's say you don't know the type of the parameter, you can first try to understand what is the type of the parameter by using one of these commands here. Basically either you can use describe or dump, both will give you more details about the parameter. So in this case, I believe we can simply just give any integer value. So let's just say 120. See, now you have successfully changed the value of this parameter called background B to 120, and you see the result that the color of the simulation window has changed. Okay, so what we have done is basically we have seen the use of get, list, set. What else we can do is, maybe let me just clean it up because we don't need all of that, but I will probably keep this list. Okay, all right. So now the other things you can do is you can use describe. So let's see how we can use this command called describe. Okay, so ROS2 param describe turtle sim. So if I don't give any parameter, let's see what it gives us. Okay, so we have to give a certain parameter. So let's just do ROS2 turtle sim, and then let's say we want to know again any of these, but you can give more than one, by the way. So if I just use the same one that we previously used and paste it here, it will give me the description, a detailed description of this parameter. Okay, as we see, it says the type is integer, and it's basically the blue channel of the background color, and its maximum value is 255, minimum is 5, and you have it increments by 1. Okay, now what else can you do? Then you can use this command called dump. So let's see what it does. So ROS2 param dump, and maybe let's just, I don't know what's the syntax, so I'm just going to say h. So basically all you need is you just need to give it the node name. Okay, so ROS2, we have 2 nodes running, so I'm just going to say turtle sim, and it's going to give me all the parameters that are associated with the node turtle sim. However, the key difference between this dump and the list is the dump gives you the results in the YAML format, and it also gives you the values that are current values that are defined for these parameters at this particular time. As you can see here, the list just gave us the list of parameters, whereas the dump gives you the actual values that are defined. Okay, and then the other thing that you can do is with the dump, one of the things that you can also do is you can actually save these values in a file on your PC. So all here in the tutorial for the parameters, which is what I'm following along basically, as you can see, list, get, set, dump here. So you can save these parameters into a YAML file. All you have to do is you just have to give the name of the file and .yaml. This will save the current values of the parameters in a YAML file on your PC in the directory where you are currently actively running your commands. This is useful because now if let's say I want to retain the value of a parameter when I kill the node and restart it, so in those cases you can basically run the node by loading the parameters from the file where you have defined all the parameters. So that's the use of storing it in a YAML file. So let's see what else is. So we have done delete, we have done describe, we have done dump, get, list, load, set. Yeah, so I have not shown the load, but that's what I was mentioning before. So basically you can, the parameters are, there are default values of the parameters that are defined, but if you want to load with the parameter values that you want to define, you can do that as well using the load command. So really that's pretty much it for parameters. If you want to read more about the parameters, there is more information available in their concepts guide. So here, I believe you go under basic concepts and you can read more about parameters if you wish. So that's all for today's video, and we will proceed to the next lecture. I think we will be covering either services or we will cover actions in the next lecture. So that's all for this one. Thank you, and I'll see you in the next video. Bye.